Let us now talk about the drain characteristics and transfer characteristics of P-channel EMOS. P-channel EMOS. Drain characteristics or transfer characteristics of P-channel EMOS. You can see, if you remember the diagram for the FET characteristics, it is exactly the same. यहाँ पे हम क्या किए हैं, उस FET के जगह पे हम EMOS को बैठा दिए, ठीक है। चूंकि ये P टाइप है तो इसीलिए द पोलैरिटी ऑफ द बैटरी जो N चैनल के केस में क्या हो जाएगा, ये चीज हो जाएगा उल्टा। ये चूंकि P चैनल है इसीलिए दिस वैल्यू यू कैन सी द ड्रेन इज नेगेटिव. This we have already seen in our previous discussion. You can see this drain is negative. This is P channel material. So now यहाँ पे हम क्या किए, FET जहाँ पे था, FET के जगह पे अब हम एक P channel EMOS हम बैठा दिए. हमको करना क्या है, how will we do the experiment to find out the drain characteristics? What we do is, पहले इसको हम 0 रखते हैं. This slider is so adjusted that this VGS is equal to 0. अब 0 रख के इसको I keep on changing. इसको if I keep on changing तो यहाँ पे क्या होना चाहिए, I should get some ID flowing. I should expect to get some ID flowing. That ID will be definitely flowing, but it will be a negligible reverse bias current, which we have already discussed in our last lecture. So that is a negligible value, so we can neglect that as well. उसको हम छोड़ के भी चल सकते हैं, because ये अगर 0 है तो you remember there is that वो parallel plate capacitor वाला जो effect होना था, that is not there. It is at 0 volt. There is formation of no channel over here, so that is why there is no flow of current between drain to source, and that is why it is off. It is off. So अगर VGS को 0 रखते हैं तो it is basically off. We can continue this experiment with VGS, giving VGS minus 1 volt. There also we may see the same effect, because the parallel plate capacitor or the induced effect by that gate source voltage, negative voltage, जो कि एक चैनल बना रहा था, -1 वोल्ट में नहीं मिल रहा है, -2 वोल्ट में नहीं मिला. Now -4 या -5 जहां हम जाते हैं, -5 volts, तब जाके we start getting the effect of that parallel plate capacitor or the induced channel effect. So -4 volt. तो -4 volt के ऊपर this curve you can see what we have done is we have plotted VDS versus ID, दोनों को plot किया गया at different values of VGS. So VGS -8, -12, -16, -20, and you remember in the last class, particularly the last line that I told you was कि जैसे जैसे हम VGS का वैल्यू बढ़ाते जा रहे हैं, वैसे वैसे more and more holes are induced between the source and drain, and they are forming a more conductive channel, and hence the more and more drain current flows, and it enhances the flow of drain current. That is why it is called enhancement MOSFET. So you can see, as we are going on increasing the value of VGS, we are getting higher values of ID. We are getting higher values of ID. ID हमारा बढ़ता चला जा रहा है. So we get this curve. This is nothing but the drain characteristic curve. अगर इसमें अब ये 10 volts पे हम एक constant line खींच दें, VDS is 10 volt, so I will get different points. I will get 1, 2, 3, 4, this kind of points we will get. तो ये point अगर हमको मिल रहा है, so then what happens is from these points I can draw this curve from here to here. This curve ये इतना ऊंचा बनाया गया है just to make you understand. Actually the curve is like this. Is like this. तो यू कैन सी वन थिंग कि एक पॉइंट के बाद जो है द वैल्यू ऑफ ID starts increasing. This is what is your VT, and that is what is called the threshold voltage, this voltage here in this graph, इतना ऊंचा बना के just to make you understand, ठीक है. The actual is like this, right? The actual value is like this. This is what? This is what? ये positive VGS देने से जो value हमको दे रहा है, that is there. We are actually otherwise neglecting the reverse bias current, जिसके कारण हम क्या किए थे, एन टाइप सबस्ट्रेट को लाइटली डोप किए थे, सो दैट वो जो रिवर्स बायस करंट फ्लो करेगा एज लॉन्ग एज VGS इज इक्वल टू 0, उसको मिनिमाइज करने के लिए. सो व्हाट वी कैन सी फ्रॉम हियर इज द मेटल ऑक्साइड सेमीकंडक्टर FET जो है, here you can see here this graph before I conclude, you can see ये -4 -12 इसको नेगेटिव एक्सिस में लिया हुआ. You can just change the axis as well. You can change the axis and you can replot the graph. ठीक है, here the negative is plotted in the positive axis. Remember this. Okay. So now what happens here is this ds is also plotted in the negative axis. You see -5, -10, -15, -20. So what happens is here we have connected a p channel enhancement MOSFET as shown in the figure. और उसके बाद हम करते क्या है, पहले VGS को 0 रखते हैं, उसके बाद VDS को बढ़ाते जाते हैं. सो वी स्टार्ट गेटिंग द रिवर्स बायस करंट विच इज नेग्लिजिबली स्मॉल, वी कैन नेग्लेक्ट दैट, हटा देते हैं. देन VGS को हम बढ़ाते जाते हैं, वंस इट रीचेज द थ्रेशोल्ड वोल्टेज, उसके बाद से क्या करता है वो जो हमारा सबस्ट्रेट लेयर है वहाँ पे इट स्टार्ट्स इंड्यूसिंग द होल्स एंड इट क्रिएट्स अ चैनल बिटवीन द ड्रेन टू सोर्स. और जहाँ ये हो गया, this starts conducting, this particular FET starts conducting, and once it starts conducting we get these characteristic curves. So that is what is there for the eMOSFET drain characteristics, p channel eMOSFET drain characteristics. Thank you.